Okay, we're going to look at section 5.1 and maybe a little bit of 5.2. And this is about transcendental functions. And in algebra, we have what's called transcendental functions. And literally that means they transcend or go beyond the regular algebraic functions. And it includes exponential and logarithmic functions. So those are considered transcendental functions. Okay? We're going to start out by talking about composites. If you had college algebra, you should have gotten this. I know you guys that were with me, we did composite functions, putting one function into another, and that's what we're going to look at right now. Here's a definition of it. If you're given two functions, and call them f and g, that's typical. The composite function denoted by f of g, and this little bitty circle, it's read of, f of g, is defined by either this, f of g of x, or fg of x. That's some different notation. What it means is that g gets put into f. In high school, sometimes they're called fog and goff. Anybody have an instructor that called them that? No, just not at all. Okay. All right. But it's literally one function is put into another function. Okay, let's see an example of how that works. Okay, so you're given an f of x that's 2x squared minus 3 and a g of x that's 4x. So if we're asked to find f of g of x, you always want to go from the far right and put it into the left. So we're going to take g of x, put it into f. So I'm going to take g of x and put it in everywhere there's an x in the other function. So instead of 2x squared, I've got 2 times this thing squared, minus 3. Clean that up as much as you can, and here's the answer, or what you get. F of g of x is 32x squared minus 3. That's what you get when you put this function in for x. Does that ring a bell for anybody? You guys have had composite functions? I know at least 3 have. Anybody else? Is that a foreign concept? Okay. Ben, Travis, you guys have had? Okay, all right, good. All right, so the opposite, if we want to do g of f of x, that means we're going to put f into g. So that's the yellow marking. We're going to take this and put it in for x here. So down here we've got 4 times 2x squared minus 3, and we get 8x squared minus 12. Okay, so if you're asked to literally come up with what the function is, this is what you're going to have to do. Put one into the other. What you're going to be doing on your homework is you're going to be given 2 functions, and then we're going to ask you, what's f of g of 1? Well, if you want to go ahead and come up with this is f of g of x, and this is g of f of x. So you've already got the function. You could take this number and plug in. So which one of those am I going to plug 1 into? Right here. There's f of g. So if it's f of g of 1, I could just plug that in. So I'd say 32 times 1 squared, so that's 32 times 1 minus 3, that's 29. Okay? I could also do it this way. I could put 1 into g. Let's do it this way too. 1 into g is what? 4. And then I take 4 and plug it in here. 2 times 4 squared. So 2 times 16 is 32 minus 3. So even if you didn't come up with these, you could put it into one and then put the result in the other one. Okay? All right. G of f of 1. Plug it in here. So 8 minus 12 is negative 4. How about f of negative 2? What does that mean?
You plug in the same formula to that formula,
Yeah, well, let's look up here. F of negative 2. Here's F. Put negative 2 in. What do we get? 1. Turn around and put 1 back in. And what do you get? Plug 1 in. Thank you. Oh, that's not. Did we put negative 2 in?
Don't we have to put 2 eggs?
That's 5. Somebody yelled out 1. Was it you or 2? I didn't hear you. I'm so sorry. Some number was yelled out, and I just took it, didn't even look. Okay, if we plug in negative 2, negative 2 squared is 4. 4 times 2 is 8, minus 3 is 5. Now, turn around and put 5 back in here. 5 squared is 25. 2 times that's 50. 50 minus 3 is 47. So you're putting it in the same function, but you have to take the result and plug it back in. All right, so that's F of negative 2. How about G of negative 1? Let's make sure we can do that. So we put negative 1 here, you get negative 4. Plug in negative 4 again, you get negative 16. Okay. All right. Now, you probably, if you're taking notes, this is important to find the domain of F of G. This is not something that you usually do in college algebra. I usually wait till pre-cal to do this. It's a little bit more involved. Okay? You could find the domain of a regular function. You know what to look for. Are there restrictions? Is there a bottom that can't be 0? That sort of thing. Well, to find the domain of a composite, here's the steps. We're going to find the domain of G, and then any of those restrictions are also excluded from the F of G. Then we're going to find the domain of F and set that restriction equal to G of X. We're going to solve that, and it's going to give us any other restrictions. So this is a little obtuse, actually. It's kind of weird. But write those down because that's going to be your path to get the answer. Find G, the domain of G. That's going to be in your new domain of your composite. Then find the domain of F and set that restriction equal to the other function. Solve that as an equation, and what you get is going to be another restriction that goes into your composite one. We're going to work a problem. We're going to see how that works, but I'll let you get that written down. Okay, so here's the example problem. Find the domain of F of G of X if, and so you're given two functions. Here's your F function, here's your G function. All right, so domain of G, told us to find that first. So the domain of G, if we're looking here, what's the only thing that X can't be? 1. So that's our restriction. So 1 is going to be excluded from the composite domain as well. We know that. All right? The domain of F, what's the only thing X can't be? Negative 2. All right, so take that restriction and set it equal to the G function. So negative 2 equals 4 over X minus 1. We're going to solve this for X. Multiply this to the other side. You get negative 2X plus 2 equals 4. Negative 2X equals 2. So X equals negative 1. That's the other restriction that's going to go into the domain of your composite function. Okay. So negative 1 is excluded. So domain of this is it can't be 1 and it can't be negative 1.
So if it was domain of G of F of X, it would be you'd plug in.
You just do the
G
reverse.
Into
You would just follow the steps but do them backwards. I mean, you'd, instead of finding G first, and you would just do the reverse. John?
So we don't include the domain of F in the,
No, no. Okay, so that would be, and you have one question like that on your homework. You'll probably have one question like that on your test. So for your homework, you'll have these notes and you'll be good to go, but you do need to practice that. Okay. All right. Let's see. I think that's it for the notes. Any questions on the notes? Okay. I brought in some examples from the book that we can look at, so we're going to look at those first before we do problems. Were you still copying? You're good? Okay, and I'm going to make this much bigger so you guys can see, because I can't even see it and I'm right here. Okay, so this is a problem out of the book. Number 7, I think maybe I even enlarged it down. There we go. All right. We need to know how to do these. All right. Evaluate each expression using the values of the table. So these are the problems down here that we're going to do. We're going to do f of g of 1. We don't have any equations. We just have a table. So remember that we always go this way. So if you're going to find g of 1, you go to 1 on the x line. What's g of 1? 0. Then you take 0, go back to the x line, and what's f of 0? -1. So this is -1. Do you see the path? You start on the x line, go to whatever's on the right, find what that value is, and then go back to the x line and find the other one. Let's do f of g of -1. We go to -1 on the x, g of that is 0, and then go to 0, and it's -1 as well. Are we seeing how that's working? All right, g of f of -1. -1, and f of that is -3. We go to -3 on the x and 8. So it's just a path that you're following. Start out at the x, go to the right one. All right, g of f of 0. So we're going to go to 0, f of 0, -1, go to -1, and we get what, 0? Question, Nathan?
So these are basically just what the answers are for an unknown formula.
Right, right. And what would happen if it said, if I said g of f of 3, and say we got a number that when you went back to the x, there wasn't anything that you could find, then it's going to be no solution. I don't know if you have one of those, but if there's a number that comes up that you can't get, then it won't happen.
It's like g of f of 4 was asked here, and they just gave you the table of individuals.
You couldn't do that. Yeah, or if the first part you could get a number, but then say the answer was 8, well, you can't go back to the x line and find 8. So it would be no solution. You couldn't get it from the data that's here. Okay. All right, the last one, g of -2. So we go to -2, and g of -2 is 3. We go to 3, and we go back down to g, 8.
Okay. And so there was a g of g -3. We wouldn't be able to do that.
Right. That's exactly right. His question was if you had g of -3, you'd go to -3, you'd get 8. You can't go to 8 on the x line, so it's no solution. Okay. All right. Do we need to do another one, or you've got that? Everybody's going, oh, I got that. That's good. All right. Okay, so let's look. That's if you had it in a table. Now let's go back up here and look at this graph, because it's the same idea. I don't know. Can you see that in the very back? Probably not. I think that's as big. 200% was all I can get. But I want you to understand what's going on here. It's the same idea. You have an x-axis. That's like your x line. You have, I think I did have this somewhere. Oh, I don't know. This is g of x right here. And this is f of x, okay? And right here is the x-axis. So we've still got 3 lines. So we're going to follow that same path. If we were doing g of f of -1, find -1 on the x-axis and go to what line? We're doing this one. We'll go to f of x. So that's this thing. So we'd end up with what value? 1, positive 1, because you're looking at the y value. Then you go back to 1 on the x, and we want to go to the g function, 4. So your answer would be 4. So we're not going to do all of those. I wanted you to see that you could do the same thing with a graph that we were doing with the table. You have an x line, you have an f of x line, you have a g of x line. You don't have equations, you have data. Does that make sense? So, do what?
We do 10C.
Sure. All right, 10C is f of g of 0. So we go to 0 on the x, and then we go to g, which is about 5, maybe? Looks like it right there.
I thought we went to the, I thought it was, we would go to the G instead first.
Well, you go to the 0 on the x line.
Oh, okay.
I'm just there. I'm not, I happen to be on this function, but I'm there. You go there, it's 5, so you go back to 5 on the x and go to the f, and what's the y value? 1. Okay? So, same idea. All right. Any questions on those? All right, then let's look at the problems. How many of you guys brought the problems? Oh, 2 out of 20. Okay. All right, we have to get serious and dedicated to the class. And that just went on the video. Okay, I'll have to cut that out. All right, let's go here. All right, same idea. Let's work the problems. This is that same thing, a table. All right, we've got 3 things to do. F of g of -2. All right, so that means we find -2 on the x, and we go down to what? G. So the g value there is 2. Then we go back to the x line at 2, and we go to f. So our answer is 1. All right. You guys do this one. G of f of 1.
So 1 on X, the X line.
Mm-hmm.
And then we find out what F is on the Y line, so that's -1. So we go -1 on the X line, and we find out G.
So it'd be 1. Okay? Everybody got that, following that path? Because you have to do that on your homework as well. All right, the last one is f of 2. So 2, and you go to f. The value is 1. You go to 1, back to f, -1. Okay? Should not be too bad. And then we've got the same thing here. Okay, I think I can make that a little bigger even, maybe. Okay. So we've got an f of x, we've got a g of x. Where's our x line? It's the x-axis. And we are supposed to find, is that g of f of -1? I don't know if I have the parentheses right, whatever. We start on -1, and we're going to go to f. So that's at what? 3. Then we go to 3 on the x, and we go up to g, and it's at 2. Okay. So that one's 2. Okay. G of f of 0. So go to 0, and then at f you are at 2. Go to 2, and up you're at 3. Okay. Okay. F of g of -1. Here's -1. You go up to the g and you're at 4. And then at 4, and you go down to f, you're at -2. Okay. Last one, f of g of 4. So you start at 4, go up to g, you're at, go to 3, and down, -1.
And these are all,
What?
no, never mind. I was about to ask if these were all the domains that can't be looking up. Well, how would this be used in a practical sense?
Practical?
Yeah.
Composite functions, I'm not sure of a practical. No, there might be. Maybe in engineering. I'm not an engineer. I don't know. Maybe. I'll ask, because I can't think of one. Where have I ever used them? Teaching.
Yeah, I know that's one.
Yeah, yeah. You'll use it practically on the test. How about that? That work for you? Okay. All right. Let's see if we can do this one. Now this one, we've got equations. So you guys could do these. I would like you to do these first, if you can see those. Back at the very back, can you guys see this part? Okay. So you're going to use these two equations, f of x and g of x, and you're finding f of g of 4. So that means you're going to plug 4 into g. Whatever you get, then you'll plug it into f. So everybody work those 4, and then we'll see what we have for the answers. Without shouting them out till the end. We'll just let everybody work on that. If you can't see, let me know. Did you get them?
Oh.
You need me to read one to you, Corey? Can you see it? Okay. Okay. All right. Somebody help me out. What's f of g of 4? 72. Okay. How about g of f of 2? F of 1? 4. And if you're not getting those, just check again. G of 0? 36. Okay. So we have looked at composites with tables, with graphs, and with equations, and asked to find some composite things. So you should be able to do those on that homework. Questions on those, on just finding those? Anybody? All right, then let's look at these questions. All right. The volume V of a right cylinder of height h and radius r is. So it gives you an equation. V equals pi r squared h. Gave you an equation. If the height is 6 times the radius, express the volume as a function of r. This is such an important application, especially if you're going on to calculus, to be able to rewrite an equation as a function of some other variable or one variable. It's really important. So, what are we going to think about to do this problem? They give us that here's our cylinder, and that here's our h, and here's the radius, okay? And they told us the height was 6 times the radius, right? So if we want to rewrite this formula as a function of r, that means we can only have r in it. So what are we going to do? Well, we're gonna take this, yeah, plug that in for h. Plug that in right there. So ultimately, we're going to have v equals pi r squared times 6r. And we could probably go a little bit further and write it as what? Just convention says you put the number in front of the pi, and then we multiplied r squared times r. Okay?
Wouldn't that be called v of r though? Or is it we really are doing v equals? Why is it different from?
Well, I just didn't put the v of r.
Oh.
Yeah. It is saying volume as a function of r. That's what v of r means. And absolutely, I just didn't write that. But just to clarify, I'll put that. You can't, I mean, that's what we use as an estimated value. The further you go in math, they want you to be exact, and to get exact, you leave pi in the formula. You know, you just leave it as pi. If they say estimate, then you might use 3.14, or you might use the value of pi on the calculator, just the little pi button. But if they want totally exact, we leave it in pi.
What would it look like if you did v of 1?
V of 1?
Yeah.
That'd be 6 pi.
Okay.
You would just, because v of 1, you would set 1 right here. 1 cubed is 1.
Okay.
So it'd be 6 pi. So that's saying if the radius were 1, what would the volume be? It would be 6 pi.
Okay.
If the radius were 2,
Okay. So r is like saying x. Okay. So
yeah.
it's basically saying v of x. We're just saying x.
Right. Right. Okay. All right. Any questions on that? All right. Now we've got two equations, and they're asking us to find some more compositions. So this is some more stuff that you guys can do. So I'm going to leave this. I'm going to make it a little bigger. I'm going to pause the video, and you guys are going to work on those. Here's the equations. Here's f of x. Here's g of x. And here's what we're trying to get. Okay? Oops. Okay, so that's what we should have gotten for those, and it looks like everybody was doing okay for that. All right. Let's go to the next one. It's a little bit different. They're going to ask us some different questions about some composite stuff. Okay, here's the equations. 8x plus 9 and g of x is x squared. They want to know what f of g of x is. What does that mean? That means put g into f. G into f. So what are we going to have for our equation? If we take this and put it in for x. 8x squared plus 9. That's what f of g is. Okay? Now, it asks what the domain of that. Oh, yes, sir?
Oh, okay. So that doesn't say f of g of x.
Yeah, that's f of
g. Would you plug x in for x, or would that make it x?
We're taking x squared because that's what f of g, that's what g of x is. Okay. And we're putting it in.
Okay.
We're doing that.
What would it look like if you wanted to multiply by x? Is it possible for g of x to actually make any sense?
Yeah, that's not composites. Yeah, composites have to literally put in.
I was thinking that.
Okay, here we go. Now, on these, you don't have any restrictions either on this one or this one, do you? There's no domain restrictions. And what you end up with is another polynomial. That's a little quadratic. So what's the domain? All reals. So you're going to have an r here. So you can just kind of look at those and tell, because there's no restrictions anywhere. All right, what's g of f? That means we're going to take f and put in for here. Be careful with that, because what you're going to have is 8x plus 9 squared. because we took this and put it in here. So you got to multiply that out. That's FOIL. 64x squared plus 144x plus 81. So that's what they're going to want on MATLAB. Okay? Again, what we end up with? Just another polynomial? What's the domain of a polynomial? All reals. So this is going to be an R. Now, f of x. What does that mean? What do? We put f back into f. So, instead of x here, what are we going to do? Plus 9. Don't forget the plus 9 on the end. And so then you're going to distribute 64x plus 72 plus 9. So that's what f of x is. That's just a straight line. What's the domain? All reals. These are pretty easy on that. And what is g of g? That means put x squared back in here. So we're going to have x squared squared. Still polynomial. So the domain, all reals. So those were pretty easy, but just making you manipulate equations and work through that. All right. Questions on that one? Okay. Now we've got one that is going to have some restrictions, number 7 and number 8. Okay. Find the domain of the composite function f of g. All right, so this is where we need to do the work, and I'm not sure, maybe I have enough room here to do that. Okay, so what is the domain of g? X cannot be 0. And the domain of f, let's just go ahead and get these out, can't be 3. So we take the domain of f, the restriction, and what do we set it equal to? To this one? Okay, and then we solve for x. So x equals 7/3. So we have a restriction there, and we have a restriction here. So our domain is going to be written. They've already got the brace x such that, and we're going to say x not equal to 0, x not equal to 7/3. So they've got the first part of that written. You're just going to put in the restrictions you found. This one's included, and then we found this one to be the other one. If you did the composite function and you actually put fg into f and you came up with an equation, you put it in your calculator, you'd see that there were issues at 7/3 and at 0. We're not going to do that right this minute, but you would see that. Okay? All right. You guys do this one completely, please. X squared and x squared plus 3. And we're going to do f of g, g of f of f, and g of g. And we're going to talk about the domain for each of those. Okay? So go ahead and do that. Okay. When you do f of g of x, it means take this function and put it into that one. So we have x squared plus 3 squared. So you're going to FOIL that out, and you get x to the fourth plus, and so many people, when they see that, they just go, oh, that's x to the fourth plus 9, and they want to forget that middle term, so be careful with that. All right, and so what's the domain of that? Yes, sir?
Do we not have to do the little fill-in thing? Like,
The what?
there's like, there's 4, 2, instead of like 4, 3, 2, 1. Do we have to do that?
No, no. All right, so what's the domain of that? Okay. Now, g of f of x, that means we're going to take f of x and put it in for g. So we have x squared squared plus 3. So what's that equal to?
It's the power of 4 plus 3.
Okay. And again, the domain. I should have given you some that weren't. All right, f of f. So here's f. So what's that going to be? Just x to the fourth, because it's x squared squared. So we're going to have x to the fourth. And that's real. And the last one, g of g. So we're going to take x squared plus 3. You have a question?
On A, how did you get x to the 4th plus 6x squared plus 9?
If you FOIL this one out, it's like x squared plus 3 times x squared plus 3. And then you can see first terms, and then you have a 3x squared and a 3x squared, so you get 6x squared. Do you remember that? Yeah. Or the shortcut, I mean, whenever I see a binomial squared, I just use the shortcut. Square this one, you get that. For the middle term, x squared times 3 is 3x squared times 2 is 6x squared, and square the last one. So that's the shortcut. Okay. All right, we were doing g of g. So we had x squared plus 3 squared plus 3.
Yep.
And so we end up with that same thing. We've got x to the fourth plus 6x squared plus 9 plus 3. And you get this. And what's the domain? Okay. Domain is going to be so important for you if you go on to calculus. A couple of people have had calculus in here, I know, and you should be able to verify that domain becomes important, stays important for you. It's going to be a big deal. All right, that was number 7. Oh, the work, I already had it done. Okay, well now it's up there too. All right, any questions on that? No? Okay.